Okay, thank you. So I'm going to do some new session. I think this first time students are going to do this kind of presentation. So I'm Rohan from Sabaragaon University of Sri Lanka, and currently student partner of Microsoft. And these are my contact details. If you want to know about anything about this presentation and stuff, or else about the student challenge related activities, you can contact me through this. So anyone can answer this question. So what is the cloud? Do you have any idea? Except Mr. Prithviraj, his past experience and do you know about this word? What is cloud? So more or less, what do you feel about the word cloud? No answer. At least you know about this one. I think you heard several times this word. Okay, no one going to answer. Is it like this? I think you know this cloud, no? So it appears in the sky. Sometimes it may give rain, and sometimes it may go away from us. So that's basically cloud, and it's same concept taken to the computing industry. Computer science industry as a cloud computing. So this natural behavior related means take as an example to cloud computing. It's like the infrastructure and other related services are given to the general customers or the users as a cloud service. Means they can use it as whatever they need via internet. Means you don't need to, as a user, you don't need to buy these softwares or whatever the infrastructures. They are on the means normally in the internet, so you can use them as you need. But remember, you have to pay some amount of money according to your package. So these are the services given by current cloud services. So there are three kinds: IaaS, PaaS, and SaaS. So you can see that there IaaS means infrastructure as a service. So basically hosting means hosting spaces like you know, in each computer or laptop, whatever the mobile device or everything has internal memory. But sometimes you may need more than that. So in that case, these services are available in cloud, so you can access them. So it's kind of infrastructure, means like the hardware or the memory. And platform as service. A simple example is Android or Windows Phone platforms. So these are available for the developers who can build application out of that and deploy it in the cloud, and you can download your phone or the even laptops, means using like Windows 8 times. So the third one is consumer part, SaaS, software as service. So this is basically you don't need to develop any softwares, already built-in softwares are there. So they are in the cloud. You have to do only one thing. You have to register them as a subscriber and you can use it. So these are three kind of things that you can see in the cloud computing arena. So according to your request, according to your need, you can do this. Means even you can consume your software as a service. Means a really simple example is cloud database like SkyDrive, Google Drive. So simple example. Just using your email address, and they will give I think 7.5 GB space I think for each email address. So Android applications or Windows Phone applications are the softwares that we can build and we can deploy it in the platform and users can download free or paid apps. So something like that. These are basic concepts behind the cloud computing. Means previously, each and everyone, let's say in myself, if I develop any software, so I have to find my target market or my consumers, or else some company needs to develop some software, they have to come to me and ask me to develop some application. For these services, using these services, they don't even need to come to the developer. They can just purchase their software or this infrastructure or else the hardware or the platforms as they wish. So basically, this is the main difference between the package software and the cloud computing software. First I get the infrastructure as service, IaaS service. So in package software, we have to manage the entire thing. We have to manage the application, means customization part and data, what are the data that we feed, and the all the other stuff. So as in IaaS, or as you can see infrastructure as service, there are two parts. You can see we have to manage all the application, data, runtime, middleware, and OS. Other parts are managed by the vendor or the cloud service supplier, IaaS supplier. And these are the other two parts. So when we come to the IaaS to SaaS, what has happened there? Basically all the things are by vendor. We have to do, in that case we have to do nothing. So this is the standard definition given for the means comparison given for the package software and the other cloud computing platforms, different platforms. So you can see the easiness for us. Means when we are using package software, I think when we are using Windows 7 software, means Windows 7 and previous version software, we have to do all those things by our own. But now, let's say Windows 8 applications, just download and use it. So that simplicity comes to the industry by using cloud computing. As I previously said, Windows 8 and Windows Phone now running like SaaS and basically EaaS, because they are giving solutions for you. Even you can log into the Windows 8 store or Windows Phone store. You can see dozens and dozens of applications developed by some other person, but you can download it as a free or paid version. So, do you know about anything about the cloud computing vendors? At least this question I need answer. What are the vendors who are developing, who are providing cloud services? Anyone? Amazon, another answer? Just say something. I need interactivity with you guys. Just say some names. If you say any company, I will accept. Because it's that simple. Most of the big companies using these technology. Sun, Google, IBM, Intel, and lots of other companies. The major banks and major finance industries, air aviation, and lots of big companies using this technology. So, but is there Microsoft? I can't see. So, do you know about any product of Microsoft? At least this question. Even if you are familiar with Flyer, at least I need answer for this question. what is the Microsoft version of this cloud computing product? SkyDrive and one other thing, Windows Azure. So I'm not going to talk about SkyDrive, I'm going to talk about Windows Azure. So today my topic is Windows Azure. So basically it's really a vast area, very big area to talk, but today I'm going to just give a brief introduction about the Windows Azure and how it works. The thing is configuration and development stuff you need more time to study, and actually I am new to this field also. I just using my Windows Live ID and using this Windows Azure platform just 2 months, so I am also new to this field. If there are anything, any mistake happen here, I am extremely sorry. I will do definitely. I hope to do 2 sessions more in future about this platform, this technology. So Windows Azure scenarios. Basically, Windows Azure is really scalable. Let's say like this: if you need 1 GB hosting space or whatever space for your app deployment, yes, you can buy from Windows Azure. But do you think about the banks and finance industries? How much they need that means how much capacity they need to deploy their applications in cloud service, as a cloud service. Any cases? It may be terabytes or petabytes. So from 1 gigabyte to petabytes or terabytes, that much amount of space you can buy, or you can use using these platforms. So you don't need to even maintain it. You don't need to maintain any separate place, any separate database in your own premises. These are maintained by the big Microsoft or whatever other people, means not in the Microsoft, but means Windows Azure, they means Microsoft maintained by itself, but other platforms they also maintain their own. So it's scalable from 1 to terabytes, 1 GB to terabytes or petabytes. And availability. If you can access internet any place in the world, you can access the service. It's available all over the world 24/7. And fault tolerance. So technical support given by most of the Windows or Microsoft technical teams when you are in trouble, and always they are updating their stuff, and they always inform you whether you have any problem. You can ask them very easily. And this is a really cool feature. You can use website for now Windows 8 apps, web APIs, social games, and device applications. There are lots of areas we can use this technology as a service. So basically you can see what are the areas according to layer wise you can use this technology. So in the data layer, drives, blogs, tables, and so many stuff. And application layer, media services, and websites. And integration layers we can use for traffic management and stuff. These are, I think these are really new for you know. And the client side, we can use this as an office application, PC, tablet, phone, HTML5 browser services, and game consoles. So there are so many features. Because of this is new for you. These are some may not familiar to you, but if you are interested in this area, you can find the ways we can use, how we can use this application in our development areas. Because most of you guys are developers in whatever field, web, phone, desktop applications, networking. So you can use whatever the field that you are in. And the Windows Azure characteristics. So basically these are the characteristics. I'm not going to explain in detail. So that's why people love to use this service There are day-to-day applications and there are commercial applications. So Windows Azure service platforms, so Windows Live Services, .NET, SQL Server, SharePoint and Microsoft Dynamics. These are the other platforms run upon this one. Previously, if we skip the Windows Azure part, it's basically the hardware, but now it's all online. So on top of the online cloud service, you can use these services and you can see the famous products like Windows Live, Office Live, Exchange Online. Why these services are using online or live? Why that online or live name came? Because this is 24/7, we can use anytime. That's why it means when you are logging into Facebook, you say you are online. Even you can put it offline. Same we can do here. But these services are 24/7 running services, most of the banks and finance industries. That's why this is really famous, because they don't even need to maintain their own staff and the hardware or whatever it is. So these are the applications according to the category .NET, let's say .NET. So we can manage workflows, service buses and stuff. These are, I think, a little bit new to you. SQL services, we can manage databases and we can use analytics and reporting services. And live services, we can use this as a contact book, or we can use this in live services as a device or identity. So basically, you just need to know about that this Windows Azure is a platform we can use, even .NET, SQL service or whatever other platforms developed by Microsoft, which is really fast and easy. And it is really easy to configure. The thing is, this is the service which are related to each other, means run under one platform. But this is running only on .NET framework. Means after now I talk about Windows, .NET, SQL Server and stuff. Is this running only on .NET? Any other languages? Do you know about anything? Think no. Any languages? Do you think any languages related to this one? Means we can use any other languages? You are not, I know, you, all of you are not, yeah, I know, this is really boring stuff because I am also tired. Because I already come 200 kilometers away from here. Early in the morning, and yeah, I'm a little bit tired also. Yeah, you can use different languages to deploy your own applications in this platform. .NET, Node.js, Java, PHP and other languages. So don't worry about this platform. If you are a developer in another language like Java, PHP, if you are a PHP developer, really good platform to deploy your application and the database or the other services using this Windows Azure as a backend. So this is the Windows Azure website. So there are even the tutorials and other related stuff according to the language. You can see the according to the language, .NET, Node.js, Java, PHP, Python, even Python. We can use even Python programs as a front end, and we can use this Windows Azure as a back end. So I'm going to explain you a little bit complex stuff now. Even the source codes and other stuff are open source, means free. You can download it in even GitHub or Windows Azure. Just go to the GitHub or Windows Azure and search whatever the area, and you can download code samples and related documentation. So why Windows Azure is really, some other languages may also integrate with this stuff. And this is really solid platform, means you don't lose any data. You don't lose any data, you don't lose any, means you don't lose connectivity anytime. Because this has a cloning facility, means when we are logging to the system, we are maintaining some Windows Azure account. So Windows Azure account kept in one server. So in that server, always cloning two different places. Means if one server shuts down or whatever happens, you don't worry about the new stuff in another server. So basically, it's really solid. Your data will never lost. That's why the financial organizations and other big organizations using this technology, because they need this reliability and solidness. So globally, most South American countries like US, Canada and Europe countries and Singapore and other countries has this Windows Azure cloud service servers. That's why I'll show you later in my presentation. When we are going to select service, when we are deploying our service, or when we are going to deploy our service in cloud platform, we have to select different areas, different regions. So the nearest region for Sri Lanka is Southeast Asia. It's the closest one. So we have to select these areas, means these range to deploy our application. Otherwise, it may take a little bit time to deploy your application or the working. And this is 99% maintained about monthly service level agreements. So you have to pay only what you use. Means if you are using any let's say database as a Windows Azure as a database, so you have to only pay about whatever amount that you are using. You can decide. There are calculators, and so you can use it according to your budget. Some other services they provide as an annual fee or the monthly fee, but no, this is really simple. You can decide what you can use and according to your bandwidth and according to your capacity. So basically this is really usable for Windows virtual machines, cloud services and websites, not in Windows but also other services can be used. So I'm going to talk about how virtual machines are working with this Windows Azure. Like not only the Windows, but we can use the open source Linux and other stuff, other servers. So virtual machine portability I'm going to talk about. So basically, currently we are maintaining our own data centers. In this concept, we are using Windows Azure as our backend. So in our data centers, basically we are maintaining our own databases, whatever the stuff, whatever the services. Here we are migrating them into Windows Azure and always it syncs. So no need to worry about our database. Even our server gone, it's dead, doesn't matter. Already all the things are back up there. So all the things are gone to the Windows Azure account. And when we request anything, it will give the service as our request. And we can migrate this service to the other service providers, and it's simple like this. We can send our Azure account details to that, means just simply sync with other services, and we can use them as our own service. Means let's say like this, we are using our own server. It has some database, so we are deploying that some things in that database. So we are going to upload those things into Windows Azure. It's automatically happens when we have a Windows Azure account. And if you want to share with them in the, let's say, Google or Linux server, just we want to select that server and click the sync button. So we can share with them. So in that case, it's really simple to share the resources among the different services or different servers. And this is how it happens. Very simple way. So we are using 3 different Windows Azure storages. So if one storage crashed or gone, what happens? It replicates in another place. So that's why Windows Azure is really cool feature for the big organizations. They never lost the data. As a sudden we lost whatever the natural hazard or whatever issue, we can replicate our data. That's why it's reliable always. And let's say this is example that we said let's say like bank HSBC. So we are having some database in Sri Lanka and we are having database some other country. So if you want to migrate our data from one end to another end, it's just one click. So it's sending the data to that server and we can create backups or whatever stuff. So continuous storage geo-replication means we can replicate this information all around the world within one click. And this is a really cool feature for websites, not only the ASP.NET websites, Node.js, PHP and other stuff. So it's really cool feature. We can access easily. That's the main thing behind this Windows Azure thing, because we are having very fast track, we are having very fast backend cloud service. So basically Windows provide this service because of the speed and the reliability. So these are really good example of this. So we have some shared information in our website. So we can means let's say like Facebook. So in Facebook we have some information we can share. Means let's say in photo we can share with our friends. So we can tag our friends. So in that case we have to replicate that same data in the other person's wall or the photo gallery. Actually what happens is the image or the data in one place just showing means just replicating that place, not duplicating. Means same data we can access in 2 places. So in that case we don't want to worry about the speed. Always speed is there. And we can have reserved spaces, reserved instances in the website. So means it's dedicated for some service. Let's say we are running some queries in the website, so we can use that queries as a reserved place, and that reserved instance can access very fast. So I'm going to talk about the cloud service. So this in cloud service we are using some service packages. So, I know these are really new words for you guys. So in that case, the service packages are basically sent to the data centers, and basically go to the data centers, and we can retrieve that data as our wish, as our need. But if let's say if there are huge traffic on our website or cloud service, what will happen? Sometimes, basically, in normal way, the servers are getting huge traffic. It takes a lot of time. But here, it will not happen. It's navigate that service, that the traffic into different locations in the same server, which are having our own data over the service. So I'm going to speed up my presentation. So we can use this for SQL database, especially relational SQL Server engines, and cloud clustered for high availability services. And so I'm going to summarize this one. So yeah, it is not familiar to you. I know this is not familiar to you guys because this is given to you as a 1 month trial for the students up to now. That's why people are not used to this. That's the basic drawback behind this. But you will get lots of benefits behind for 1 month trial. That's the main drawback, because within 1 month we can't study each and everything because we are undergraduates. We have lack of time because of assignments and studies, other stuff. So, but still they give this to you guys. So if you are really interested about this one, just go and see. Today I just introduced you about this topic because within 30 minutes I can't do anything about the backend services or coding stuff. But really cool features you can get in the free account. 750 small computing hours per month, and 10 websites. You can deploy 10 websites, 10 mobile services, and 1 SQL relational database. And the most important thing is 35 GB storage with 5 million storage transactions. That means if you want to deploy some really cool application, means let's say if you have a really brilliant idea which can serve millions of customers, but you don't have any good backend cloud service or database, so just go and deploy this application to cloud service. You have 5 million storage transactions. 5 million transactions you can do within 1 month. So that you can use this one as a test trial for your application. Then later on you can outbound 25 GB, and yeah, there are so many other things. So you can get the documentations or the whatever the helping documents from Windows Azure site. And there are so many other reference documents related to Windows Azure. Just go and read this and use your Windows Live account and log into this Windows Azure service. But you need Sampath Bank web card or the credit card. Just no need to worry about the money. Even yesterday I activated my account without zero money at Sampath Bank web card. So no need to worry about the money. So start now and start accessing the windowsazure.com. So this is brief introduction stuff. So this is Windows Azure account, my account. So you can see websites, virtual machines, mobile services, cloud services, SQL databases, and other cool stuff are there. So you need to do please. So I don't have my internet connection, so I'm going to just explain. If you want to deploy any mobile service, just go and click the mobile services. Then they show you what kind of mobile service that you need. Means Windows mobile service, or the other mobile service that related to the means Android or whatever stuff. So just go and click that thing and just select whatever the path that you need to deploy your mobile application, and you need to give some name and click. They will create it for you. So in that case, you can use it as your backend. I'm going to explain a very simple thing. Last Imagine Cup, we developed some mobile application for image processing. Yeah, Windows Phone have a slight issue with Windows Phone 820 has slight issue with image processing. So in that case, we don't have any means enough processing power to deploy our algorithm. In that case, we tried to use this Windows Azure, and we deployed, means just go and implement our code in there and do some connectivity stuff, means configuration stuff, and deploy it. this is a simple example using Windows Phone cam. It has 8 megapixel cam, and the resolution is 800 to 480 pixels. So in that image, using Windows Phone processor, it takes 15 minutes to process. That much of latency was there in the Windows Phone because of that complexity of the algorithm. But using Windows Azure, it takes only 15 seconds. Same resolution, 3 seconds for upload thing and 3 seconds for download thing, 10 seconds for the 9 seconds actually, 9 seconds for the processing. So that's how we can speed up our process. So 15 minutes means 60 by 15 reduced to 15 seconds. So that's how this can be really beneficial for you. Just go and study about these things. So I'm going to conclude my session. These are the documentation part you can see in the Windows Azure, and these are execution models, and you can simply this is the simple way you can study about the Windows Azure. Just go to Microsoft Virtual Academy and log in with your live mail address, and there are lots of Windows Azure tutorials and exams are there, so you can just go through it and learn it and face the exams. Then you can actually learn about what is Windows Azure and how it can be useful for you in future. So thank you for this opportunity. Thanks. Are there any questions about related to this one? The first 2 days I was really messed up with my stuff, means even I don't know how to configure these things. Means they are really hard to do these things. But later on I got to know this is the coolest feature I can use for my web applications, phone applications and all other stuff. Because the response that you get using your own processors in your machine is pretty much high. But using the cloud service, you will get really fast responses. So in that case, we feel really happy because what the hell happened in this computer taking 2-3 minutes to process some algorithms, but it will give this Windows Azure help us to reduce that into I think 10 to 15 seconds. So waiting 2-3 seconds means 2-3 minutes means sometimes even we may sleep. Yeah, in the midnight we may sleep, no? Yeah, when most of the coders are working at night, definitely they will sleep. But using Windows Azure backend, you can't sleep even there. You have to work hard. So thank you very much. If there are any clarifications need for this one, just contact me. And I will do another presentation a little bit more interactive than this one. I'm sorry about the interactivity today. Okay, thank you.
Thank you, Hana. Our next presenter is Mr. Prithviraj Kulasingham. He is a familiar presenter in our Exchange Chance Council meeting. So he is the Microsoft MVP for SQL Server and also the database architect of PSN Lanka in global technologies. I invite Mr. Prithviraj Kulasingham to present to you about SQL or NoSQL. What is the good things and what is the bad things and ugly things about them.
How many of you guys are in the first year? Okay. How many of you in the second year? Right. Third year, fourth year? Okay, thank you. Right. So I'm actually going to talk a little bit academic. It means, to be frank, I'm a Microsoft MVP, but I'm not going to talk about a Microsoft product 100%. I'm going to compare a couple of products in the database market, because right now in the database market there is a big change happening. So I like you guys to know about it because it is going to be useful for you. Right. So You all heard about the word SQL most probably. SQL stands for Structured Query Language. But generally this SQL is used as a language to interact or connect and query with the relational database. Right. So now there is this new trend has started called NoSQL. This NoSQL does not mean no to SQL. It actually stands for not only SQL. Okay? Right. So that is my topic I am going to talk. And in case if you want to know about me, okay. So you call me Preeti Raj Prasingam. I am currently working at Pearson, Lanka as a database architect. I am an architect, database architect, not only to Pearson Lanka, but actually it's a global company, so it's a global level role. Actually, I started working with databases in 1991. Those days, SQL Server was not there. We had some other stuff like DBase, Clipper, those type of things were they called databases. Then I started working with SQL Server in 97, end of 97, yeah. And in 2011, almost 2 years ago, I started working with these NoSQL databases. So that is my background, and I normally talk lot in the user group meetings. So in case if you have interest with databases, I will invite you all to come for the user group meetings. Next Wednesday we have one in this same building on the 11th floor. So we are happy to have you all. Right. Having said that, now let us start with the characteristics of relational database systems. So if you take a relational database, generally you have a centralized database which is actually used as a repository to have all the data. Now this data is normalized, this data is stored in such a way that you can store the data fast. And then what happens? You also create all the relationships so that there will be no ambiguity of data, or there will be mismatch of data. And then what you do is you write a whole heap of applications around that. Now, what happens? Let me say there is a company which started somewhere in 2000. They started this database. At the time there will be some developers who have written an application. Over the time there will be another application coming. There is another two applications. There is a reporting framework. People would have left, people would have died, people would have gone somewhere else. Some applications are still used at low key. Nobody knows what exactly is happening. Now what happens? This database stays with all the data. It's grown into terabytes of size. Now we get into trouble in maintaining it. Right now, our company has more than 50 terabytes of data in SQL Server and almost 100 terabytes of data in Oracle. And we have NoSQL, we have MySQL, we have everything. Right. Now think about it. If there is a small maintenance work we have to do, we have to copy the database from one place to another. It is basically not a minutes process, which is not an hourly process, which is sometimes a day's process or a week process. If there is a problem for us to recover that, we will have to spend hours. At the time, the application is down and the customers are screaming. Right. Now, additionally, we have some other problems. Actually, this relational database system started somewhere in the 70s I would say, or early 80s. Now basically 30 years have gone, right? So now the problem is, the relational database system came to solve one problem. We have some other problems. One example, when we started computing, we were restricted to a building generally. It could be a lab, a room, a building, or maybe a village. Now we have gone, passing the country limit, we have gone a global organization. That means you can't have a downtime. Now, right now, it is, okay, almost 4:30 here. It is 2 a.m. somewhere, 5 a.m. somewhere, 8 a.m. somewhere, right? Midnight somewhere. That means there are a lot of people using all the time the system. So, we have a problem with these central databases because you have only one database, you can't afford to give a downtime. Then you get into another set of problems. Generally, relational databases are rigid schema. Think about, you have a table of 5 billion rows. You want to add a column. You know what will happen? You can't just add a column. You have to add a column either with the default value or with null value. If you are adding with the default value, your table is locked until all 5 billion rows are updated, which will take a few days. Think about, you have a transaction table, you want to add a column because there is a new tax has come or new requirement has come or something has happened. World is always changing, right? So your application needs to change, right? Then what happens? You go and say alter a table at this column, default 0, press the enter key, leave and go off, switch off the phone as well. Right. And then the other thing which is quite addressed by the business, by the products as well, is when we started this relational database system, the data type we used are basically integers, decimals, some string, date, time, that's it. Now we got into a whole heap of complex data. Now you have videos, you have photographs. Now the problem is we have addressed to some extent that you can store photographs, you can store videos. But now the problem is even more complex. People are asking, can I search by a particular feature in a photograph? ISR at least. Can we do that in relational database? We can't. Right? Okay, I will give you another problem. You have all used Facebook. Is there anyone not having a Facebook account? I have, so I can't recommend. No one. Wonderful. I know you guys are very scared to raise hands to talk, so I'm putting the question in such a way. Right? I'm not asking you who is having account, who is not having. So no one is raising hands. Good. Right. Now the problem is you would have seen this. In Facebook you have your friends. Now your friends, they have more friends. Now those friends have more friends. Right. The same thing you can see in LinkedIn. Right? You connect to somebody, through that you find other connections. Now, if you think conceptually, it is actually very difficult to implement. When you get all these things and connected, and also then you find the people who have the similar eating habits and the similar interests and things like that, it becomes so complex. Right? They created a database and relational system. They created with 2,000 entries. They ran in MySQL. It took 2 seconds to resolve this relationship. Then they created in a graph database. Right, I'll come to what is graph database. Which also took 2 seconds. Then they increased this data from 2000 to 2 million and ran in MySQL. It ran for about 6 hours. In graph database, still it is 2 seconds. They increased it from 2 million to 2 billion. They ran in MySQL. It was running for about 4 days. Then they couldn't wait anymore. They basically stopped the process. In the graph database, still completed in 2 seconds. Now this does not mean MySQL is bad. MySQL is not designed to solve that problem. MySQL is designed to solve some other problem. Like that, relational databases are designed to solve some relational problems. Like you have a business transaction, you can do it. If you want to have a simple student management system, you can do it. If you want to have general business application, yes, you can do it. If you want to have a bank application, you can do it. But when you go into specific issues, okay guys, now since you are all using Facebook, I'll ask you a question. When did you last saw Facebook was down? You tried to log in and anybody have seen Facebook down? You couldn't connect to Facebook? Anybody? No. Okay. Still have to keep the question. Right. Anybody seen Google down? You have seen Google down? No. Anybody? Okay. Anybody ever experience the fixed relationship? That is another thing. For example, if you have a customer and if you have a product, say order, you have a relationship customer and an order. Can you say that if this order has the type of X, then connect to this customer, otherwise connect to the other customer, otherwise connect to a supplier? Can we have that in a relationship system? You can't. Relationships are between entities, not between the actual rows. So you can't say this row connects to this supplier, but the next row connects to another customer. It has to connect to the supplier. Right? So you have a little bit of rigidity in your database design. Now this brings the problem. Now, I think you might have heard about this word agile, right? Anybody not heard agile? I think I have to congratulate you for putting the questions in that way. Right. So in agile, now you start developing things as you know some requirements, you do with that. Right? You don't have to know the entire system to start the development. You deliver whatever the first part. Right. Then when you go to the second part, you definitely need to make some changes. That means your database cannot be rigid. So, 30 years back we found this relational system which is not coping with our agile model, because actually this relational database system came when we have waterfall as our main mechanism. Right? At that time you will know the entire requirement, you have to design the database based on the requirement, then you start developing on top of it. Yes, for that. Right. Okay, I already told about okay, another thing. Even when you are adding some new column, the column is added on date. Whether that is applicable or not applicable, that column is there. What we do is, we put a default value and interpret that as not applicable. That's what we are doing. We say if it is 0, it is not applicable. Right? So we are doing some interpretation on top of that because of certain other limitations. Right. So, I think I have told a few things on that central repository. Now, relational database relies on the principle that database should be the central. Otherwise, you can't have relationship. If you have customer in this location and some other database somewhere else, you can't create a relationship. It has to be in the same server, because on top of that there should be a management system running which needs to control this relationship. So when you are entering a transaction which does not have a valid customer, it will throw you an error. Right? So that the management system has to run, for that the data has to be one place. Now the problem is, when the data grows and grows and grows, this laptop is not enough or your desktop is not enough, you have to buy bigger server. You have to buy additional hardware. You have to buy larger hard disk. Not only hard disk, now you can't just go with the hard disk, because hard disk maximum you can have about 3 terabytes, 5 terabytes. Now what you have to do, you have to go with the SAN, storage array network. For that, you need special hardware which has to run separately. You need to connect it. The cost is exponentially growing. Now we have a problem. I told you this central repository, so that server needs to work all the time. So you can't just put any memory, any CPU, any motherboard and work. You have to get thoroughly tested high-end servers. Cost goes high. Right? For example, some of the servers, whatever I have heard, just the server, right, with the basic maybe 1 GB of memory, right, which has the expansion slots to add about 64 CPUs. Each can be an 8-core or even 24-core CPU. Just the server cost about $100,000 US, right? It close to about 13 million rupees in our. You can buy a house more than, right? Then the other problem is, because of the data growth, whatever happens, your performance comes down. You know, we throw any amount of hardware, still your performance is not growing in the same way. It is coming down. Then, as I told you, maintenance is a different thing. So there are some additional features added to solve this problem. For example, now SQL Server supports hot and CPU. You know what that means? While the machine is running, you can just insert a CPU. System will understand and take care of and will start distributing. Like that we have hot and disk. Okay? So it is like, you know, the doctor is doing a heart surgery while the patient is live. Live is not a right example. While the patient is walking. Right. So these features actually cost a lot of money. Now the problem is, that means Facebook should be banned by now. Because they have whole heap of data for that whole heap of servers. For every server, they are going to spend millions of money. The company should have been banned. Then the other problem with relational systems. Relational systems are not designed for data or disk storage failures. Because of that, we have to put weights. Because of that, we have to add additional hardware and hardware-related technologies to maintain it. For example, let me say one of your file is corrupted. When you run a query, you will get the error. That means the application is not designed. It is not the fault of SQL Server. It is the technology is there. It is designed that you have a central repository, you have the data there. So if the data is not there, it has to go away. So we put all these high-end stuff to solve and it becomes our first ghost file. Company's con server. Now, for that they came up with a different approach. Why can't we, instead of growing one disk, why can't we spread this data? Then there is some intelligent guy came up with this theorem called CAP. Right? What it says is consistency, availability, and partition tolerance. Let me explain what it is. Consistency. When you query something, you always get the same data unless the data is changed. Right? That is one. Availability, I think you all know, right? The data is available. Third thing, now if the data is spread across multiple nodes, right? Partition, that is partition. Partition tolerant, that is, even if there is an issue with these partitions, they can't connect to each other, still the system should work. Now, these guys came up with this theorem saying you can't have all three available all the time. Not all the time, at any time. If you can make only two things available, not all the time. So if you see this diagram, there is no intersection of all three, that is empty. Right? You can make only two available. Right? Okay. So there is big proof. I'm not going to go into this much into that, but assume that yes, it is true. It's not available. Now, what we have in the NoSQL databases, understanding this CAP theorem, they try to address some the same problem in a different way. First of all, so this NoSQL, the word is actually coming. Okay, before going into that, let me explain one more thing. Okay, let it come and later let me explain. Now, I told you there are these three things. Now, when you have a centralized database, there is no partition tolerance. Agree? Because there is no partition. Data is not partition. It is in one place. Right? So, in a global environment, it is becoming a problem. So, people are thinking about why can't we have? Like, for example, now US is almost about 9.5 hours, 10.5 hours to about 13.5 hours, so 12.5 hours different, because in US there are 5 time zones. So basically, if you take Middle East, 12 hours, right? Basically, they are, when we are up, they are down, when they are down, we are up. When their administrators go to bed, our administrators can take care of their servers. But when both want to run business together, for example, Americans also using Amazon, we also using Amazon. That means Amazon can't go down at all. They can't have a downtime. There is no proper downtime available. So, why can't we have two different servers? You know, only this Asian people address this Sri Lankan server and the American people address the American server. Then you have a problem where to get the product. You have to synchronize this data. Right? The data should be shared. Okay. Then you have a problem. When if you like sharing these servers, like 2 servers, 4 servers, 8 servers, 25 servers, okay, you have 100 servers. I'll tell you, at any given time, at least one server is down. Agree? When you have 100 odd servers, each of these servers will have some upgrade time, some server issues, some hardware upgrade, some memory failure, all those things happening at any given time. This may happen only once in 100 days, once a year. But you know, you have so many servers, it's like anytime something is down. Right. So, NoSQL databases started with understanding that as an acceptable issue. That is, this is going to happen. So let us build the application understanding at one time the data is one server could be down or some servers will be down. So you know what they came up with? They came up with data does not reside in one single place. Data resides in multiple places. And at the same time. But you will not have all the data in one place. You have some data, let me say Sri Lankan data will be in Sri Lanka as well as Singapore as well as Africa. Right? So if Sri Lanka is down, you can use Singapore. So if both are down, at least you can use Africa. Right? Like that, the data is replicated at the same time. You don't have all the data here. So for example, Africa's data may be here, Africa and America. America's data could be in Africa, America and even in Australia. Australia's data may be in Singapore as well. So that every data is copied somewhere. But also share, segregate. So that your data does not grow too much, so that you don't need these high-end servers. You can buy small servers and maintain it. Right? And also, if one server is down, still some other server is there to give you the data. That is the concept behind this NoSQL databases. So, one important thing, NoSQL databases is not one model. Because this is like mushroom. Now there are about 120 different products available. I have studied only about 4, I will say, or 3 I will say. Fourth one I am trying to actually, right? So it is too much. There are many things happening. Everyone is trying, right? But there are 3 key products which are really, I will say, matured a little bit, and they are up in the market. One is document-based databases. Other one is simple key-value pair type of databases. Third one is called graph database. Of course, you have SQL Server like a row model and everything also there. So what I mentioned as sharding is basically your data is segregated across multiple places. And they do not, some of them do not support consistency. They compromise on consistency to have availability and partial performance. That means when you query something, like if you are going to get the data from multiple nodes, sometimes you may not get the same number because one node is down, you may not get data from there. The rest of the data is given. For example, we are going to Amazon. In Amazon you open a product. Let's say you are searching for a camera. At the bottom you will be seeing there are about 4 people clicking their reviews. It's not exactly 4 people wrote the reviews. There is about 400 people wrote. It picks just 4 people and shows you. So if you go to the same product next time, you may not see the same 4 people. You will see some other 4 people. That is fine, after that knowledge. It does not have to show all the same time, the same people. Right? Okay. So that is what called, that is consistent. Also, now let me say you are saving some data. I told you now, okay, Sri Lankan data is saved in Singapore as well as Africa. Now let me say African server is down. You can save in Sri Lanka, you can save in Singapore, you don't save in Africa right now. When the African server comes back online, after your maintenance work, at that time we go and apply. So eventually the data will be there, but at this time it is not there. Right? That is the model of NoSQL database. Most of them. Okay? Right. Okay. Right. So this is something I wanted to show you. I do not know why I put it after that. It should be coming before NoSQL. Right. So these are the 3 areas I mentioned about FTR. Right. So there are relational databases concentrating on 2 sides: consistency and availability, but they don't have partition problems. right? So there are so many other products. So Amazon created something called Amazon Dynamo. That is their proprietary one, right? Now what they have done is, some people left from there, so they know how the model works. Based on the same model, they have created Cassandra, and it became open source. It's available. The same model is used from Walmart and CouchDB. React I have not studied much, but that is also using the same thing. Then there is the other model which is not considering much of availability but consistency and partition problems. So Google came up with something called Big Tip. That is the key product, right? That's why I asked you a question. When did you last see Google down? Right? So, and when you search, have you ever got an error saying sorry, particular node is down, so that you are not getting it? How many of you know how many servers Google has for your search request to answer? Any guess? 100? 1000? Okay. How many of you think it is between 100 and 1000? Please stand here. Nobody? So everybody thinks it is less than 100?
More than
1000.
More than 1000.
More than 1000. Okay. 10,000? Between 1000 and 10,000? Okay, what could be the maximum number? 20,000?
40,000.
20?
40,000.
Okay. Any other number? Just tell a number. Okay, I'll tell you. I heard this number from a guy who visited Google. 1 million. And those servers are not what the servers what we call. Actually our desktop machines. Because when you want 1 million machines to run, better to get the cheapest ones. Add enough hard disk. Right? That is the cheapest solution. So those machines may down at any time, right? You know about our machines. Right? How many problems you would have had, right? So they built the system, yes, one will be down, so copy the data somewhere else. So if this is down, you replace it with another one. That's how it is running. So always faithfully is serving our. Sometimes it's very difficult to understand what we are asking, but it always gives some answer. Right. Okay, guys, I'm quite behind. So there is this type of products. So actually, I will say there is one more product I should have mentioned, which is not there, called Titan. Right, Titan and Neo4j are cloud-based databases. Right, Neo4j is actually made a little bit of big name in the market, but Titan is basically sounds like more stable. Right. MongoDB, I don't know how many of you heard this. 1, 2, 4, 3, 4, 5, wonderful, good. Right. Actually, there is a MongoDB user group as well which is functioning. If you guys get a chance, I don't know, I think it happens only once a quarter, I think. Right. If you get a chance, please enter. It's useful. Right. Especially when you are students, better to get to know all those things. Right. So that when you are gray hair, you don't have to spend time in study. You got my point, right? Okay. So Cassandra is another one. Recently I went for that particular training and I found it very fast, extremely fast, right? And that is designed for KPI writing. So actually I met a guy who is actually working for a medical company. What they are doing is, especially in the Western countries and all, when a doctor talks to a patient, everything they speak is recorded. So these people have written a software which actually listens and converts that to text. Speech to text, right? Only on medical side. So all this data is kept in Cassandra, he actually mentioned a few petabytes of data. That is basically 1 petabyte is basically 1000 terabytes, right? 1000 terabytes means it is into 1000 gigabytes. So that much of data, and they are processing daily about 3 terabytes of data. Okay, and they are using Cassandra. So now you can understand how much of work involved in that. And it is all in, I think about 300 odd servers they are using. Right. So Redis is actually in-memory database. It is not a storage-based system, but it is very fast processing power. So people are using it. And interestingly, I recently found a place where they are using Redis and SQL Server together. Redis for caching. Right? We will talk about it maybe on another day. Okay, so right. Okay, now we will come back to SQL Server. So now I mentioned about all these products. You may be wondering when first of all, I want to tell you that this is not Microsoft's marketing campaign, right? This is for you guys to learn things, right? So don't worry about it, okay? So Microsoft, you can't call this SQL Server as a relational database anymore, because it has so many features of non-relational databases. For example, it supports XML, option, file tables, right, and relationship to triggers. And actually, there's a project which is going to be released next year, with next SQL Server 2014. Sorry, 2014. It's an in-memory database. Hackathon is the name they have used as project, but it is going to come in 2014. Right? So it is named as post-relational database, but it is not yet. It is actually still a SQL database. Right? So SQL Server supports strict consistency. When you save data, that data will be saved consistently. When you query data, always, unless the data is changed, it always returns the same data. Otherwise, error. Okay? Right? And distributed transaction is supported. You can have multiple, but all nodes has to be alive and connected for system to work. Okay? Then ACID properties. I'm not going much into details. I think I have lost a lot of time. So when you have ACID properties, which is good, but that has a cost of performance. So and failures are exceptions, those are errors. So because of that, we are building things around that. Of course, SQL Server supports some of the features like failover clustering. That means when one server is down, another server up and it keeps the data. Right? So there are certain things built. Or mirroring. When one server lost the connectivity or server is down, another server with the data can run and give that data. Now with SQL Server 2012, I do not know whether you heard about it, always on, which basically you have the data in a geographically different place. But still the data is as whole is kept. That means you have some high cost around the data maintenance. But non-relational databases, on the other hand, they actually remove this transaction, ACID properties, all those things. Transaction is gone. That's why it is called eventual consistency. In SQL Server, let me say you begin a transaction, you put first insert and you put the second insert. If your second insert fails, your first insert has to be rolled back. Right? You know what Cassandra does? If your first insert is fine, certain insert has failed, it will inform you, okay, your transaction is done. And when that server comes online, it will go and apply this change. So if you immediately query, you won't get the data. Right. Then the most important is the amount of data should not affect the physical time, which is again the data. Because when the data goes, definitely the performance is going to be good. Right. And storage failures are mitigated through replica sets or data replication. Okay. I actually planned for a demo, but since the time is gone, I just want to give a small brief and about this topic. So MongoDB is basically a document-based database system. It's a JSON object, so it's easy for developers to write code, right? And not for transaction-based systems. Scalability and performance are actually the wording is wrong. Scalability and performance are the major problems addressed in MongoDB. Distributed database is supported, but there is no SQL language support. It supports its own query similar to this, but its own query language. It is more like I will call it as a JavaScript type of thing, not a SQL query. You say object.insert, object.update, object.find, right? Things like that. Whereas it's for read-heavy systems, but it allows a lot of complex documents to be stored. Okay, I come back to Cassandra. Cassandra is a row-based database system. It is for heavy transactions, heavy writes, but it is also not supporting transactions directly, but eventually it will support. Actually, I heard that they are planning to have some lightweight transactions. We have to wait for that to come. It supports SQL language, which is Cassandra query language, which is like SQL statement, like insert, include, create, table, all are there. But there are few things not there. There is no joins. There is no order by, because you can't order by because what if the data is not there, the top data is not there. You are going to get some data in here. So that is not, you can't use order. But when you query for one particular row, you will guarantee you will get it because you have it in multiple places. Otherwise you will get an X. Okay? So that is basically about these products. So one important thing is, generally relational database systems read the data to memory and then they write in memory and then they go back and save. Cassandra does not read, it just writes in the bottom. When you want to read the data, it constructs from different sources. Right? I am not going into the details. So that is basically about this product. And sorry, I am going to skip the demo because of the time. And simple answer. So you heard about relational and non-relational. Don't think that non-relational is going to be. One key reason, they are just starting, they are not yet mature. And they can't support transactions, right? They can't support a strict consistency model. But this is an alternate, right? And what is going to happen? They are going to coexist, right? So when this NoSQL came, there is a big oh, is it the relational database system is going to die? No, it is not going to. Right? And more, when I go through these products, I see a whole heap of problems they have because these products are not yet mature. Right? There are a whole heap of things that have to be introduced. Some of the products are there, but no proper monitoring tools. Right? So if there is anything going on, how do you handle it? But one area they have done well is when the data grows, you spread the data and you manage. Okay, I was given 1 hour and I think I have finished in 1 hour. Any questions? Hey guys, are you up? Oh, the whole hour you were sleeping. Right. Actually, I put down. Just making it right. Any questions? Okay. Thank you for listening, and hope it's useful for you. Thank you.
Mr. Vinay Yadekar from Woodrow Malaysia Holdings. He will speak about the Green IT topic the first time in the MS Chance meeting. So he is also a former networking lead of Millennium IT. I invite you, sir. Please address the present.
Good evening, everybody. Okay, how many of you heard about this green IT and green concepts? Is it a new word, new term for you all, or is it the first time you are getting in touch with this term? Come on, guys. What is this green IT and saving carbon? No? Okay. First of all, let me introduce myself. I think Prabhakar has given an introduction about me. I'm currently working at Carson's Cumberbatch as a manager LTD, and I work at Millennium IT as a team lead, more into communication, because my BSc I'm into telecommunication. So I work at Millennium IT as a voice consulting engineer, voice technologist. I guess that most of you are into software background. Am I correct? Is that so? Anybody into telecom or networking or any ICT side? ICT sector? Nobody? Okay. I think in the previous session we heard about that there are million of servers functioning at Google, and so we'll be covering like the green IT. So what is it? Because most of these concepts are well known to you all, but I'm putting it in your bag and adding a tag called green IT. Green means it's the environmental friendly concepts. Okay, we'll be discussing what is this green IT and what are green initiatives. Currently, because these green concepts are emerging in Sri Lankan context, say that government has there's an environmental authority called CEA. It's called Central Environmental Authority. So there are green awarded organizations in Sri Lanka. There's one company, only one company, who awarded for this green IT. Anybody aware on that? They awarded for the bronze medal from the Central Environmental Authority. That is nothing other than Virtusa, right? So we'll be discussing these green initiatives like virtualization and consolidation, energy efficiency, and carbon reduction and hazard disposal. And then we will be getting into these green IT solutions. So what are the green IT? So how can we reduce carbon footprint? How can we reduce the carbon that we are dropping to the environment? And how can we save the environment? So what are the IT solutions around this green IT? So we'll be discussing that part, and finally the Q&A. Okay. So this is just what I have extracted from Simon Martinez from the Gardner report. It says that the study and practice of using computing resources in a way that helps to reduce energy and operating costs, enable sustainable business practices and reduce the environmental impact. So this gives us a good message, because green IT means it's targeting, reduce the energy and reduce the cost, then the environmental impact of IT practices. So this is in a nutshell says that reducing the carbon and reducing the energy and saving the cost and saving the environment. So basically green IT means this. Okay? So this is another attempt that I have taken to show you that the technology and the impact to the environment. You can see that here you see that United States that the emission gigaton of carbon dioxide to the environment, that is 7.2, right? So they are very developed. They are using the latest technologies, latest IT solutions, right? But the carbon emission, see the carbon dioxide that they are dropping to the environment, it's very large. So Thailand, Indonesia, Brazil, so they are getting closer to them, right? So one side of the world that they are very developed, but the downside, that the bad side of it is that environmental wise, it's getting affected, right? So in this session, I'll be discussing the solutions that around this IT. So how can we reduce this carbon footprint, and how can we reduce the energy, and how can we save money? So that is the aim or the vision of this session, right? Okay, so mainly I think these terms are very user friendly, like well known to you all, I hope. Virtualization and consolidation, energy efficiency, travel reduction and asset disposal. So mainly this saving the energy, right? And these green light initiatives can be categorized into these two areas: virtualization and consolidation. How many of you are aware? Virtualization? Come on guys, just would be great that if we could have a interactive session, because since this is a new area for you. And energy efficiency, that's where this power saving, by applying power saving mechanisms and reducing the energy, right? We all know that in a OS itself has some power saving mechanisms, right? Like hibernate options and putting into the sleep mode, like that, and server room power management. That all comes under energy efficiency part. And travel reduction. There are many IT solutions to reduce travel, video conferencing, voice over IP, unified communications, like that. And asset disposal. Right? So disposing assets and reusing, refurbishing, like that. How can we apply it in a way that to reduce the carbon, reduce energy, reduce the cost, and saving the environment. So again, this is what I discussed previously. So if I further getting into virtualization, consolidation, it can be categorized under mainly three: server virtualization part, and desktop virtualization, and storage consolidation, application virtualization. This all comes under this virtualization. So mainly that by virtualizing the environment, or by consolidating more servers, we can save more energy. So I have more statistics on that later on. So we'll be discussing those stuff. And energy efficiency, let's say the server room power management, IT energy measurements, desktop, team client, are comes under energy efficiency. Travel reduction, as I mentioned, that by applying remote conferencing, collaboration, like technologies, we are reducing the travel expenses. And not only that, even many organizations are motivating their workers to work from home. That's called work from home environment, like remote office concepts. By giving VPN technologies on top of IPN, they are connecting to their offices from VPN clients and working at home. So they are motivated. By having these telecommunication strategies, they are motivating their workers to work at home. By doing that, they can save the space, the cost for the space, AC cost, electricity cost, and not only that, even they can save the travel cost as well. So that is travel reduction and asset disposal. That's where this IT equipment recycling comes. We all know that IT equipment, it has a very short product life cycle, right? Agreed? So every 6 months or every 8 months, there's a new release. Best example, Samsung phones, mobile phones, Apple devices. Every 8 months, every 6 months, there's a new release. So how are you going to dispose these humans? Right? Is there a way that we can reuse it and save the environment? So that comes under the disposal. So green ID, if you take, it has main these 4 pillars. One is, what is that? Virtualization and reducing the carbon footprint. Then again, applying energy efficiency mechanisms and best practices, saving energy. And again, are you with me, guys? Travel reduction, okay, thank you. And as a disposal. Now we will see what are the solutions that comes under each of these pillars. Okay? Right. Virtualization and consolidation. So mainly this virtualization, as I explained, that generally categorized into these 3 areas: application, desktop, and server. Right? So let me get into this server virtualization. Anybody aware of this server virtualization? Like, have you all worked with server environment or in a virtualized environment? So it's nothing like we have the hardware resources, right? With the help of this hypervisor, that is, mean it's the middle layer between the hardware and the OS. So what it does, basically manage these resources and building virtual instances. Right? So on top of this hypervisor, you have partitions. Or I would say that it's the separate OS instances. So this hypervisor is the main thing. So in this case, that is Windows Server 2008 Hyper-V. So there are, in other vendors like Cisco, IBM, they have their own proprietary hypervisors. So which will link with the hardware resources and the OS instances. So on top of that, you can have your child instances, child partitions, and parent partitions. So by doing that, even in organization, so we have virtualized blades, right? That means blade servers, we have virtualized up to 160 instances, right? So what are the advantages by doing this? Mainly, this is another representation. You can see that on top of hardware, we have operating systems and multiple applications on that. So that means that the functionality or the computation power of a single application or a server, it's divided among multiple instances. So by doing that, so it will reduce the number of servers. Definitely, if it is reducing the number of servers, it might get directly effect to the electricity. So anybody aware on the power consumption of a server? What is the watt or the power consumed? So it's huge, right? Because I'll get back to when I'm describing the energy efficiency part, you can see the statistics. So it's huge. So by reducing the number of servers and consolidating into a one base server or one server platform, we will help you to increase server utilization, reduce cost of space. That's another thing, because when you in a server room environment, you need to think about the AC and the electricity and the space, because space is more important, rack space. And another good point is easier to restore. That's another thing. So when you have multiple servers in a server room, when a server is just assume that there's an issue with the one server, but in a virtualized environment, you have the luxury of restoring it quickly than a normal one, because it's matter of just taking a backup of a virtual server and restoring it on top of that hypervisor. So there's a technical term called vMotion. That means virtually you can move one server to another server. So even a BCP situation, business continuity, or a DR, disaster recovery situation, you can easily move one server instance from one server blade to another without any issue. So you don't need to bother about hardware resources, you don't need to bother about the transport and carrying it and make it up, but it's a matter of just moving it from one blade server to another. Okay? Right. Another virtualization, you remember, just recall the first slide. I was describing about the server virtualization. Now I am getting into this next generation computing. We call it a simple end computer. Just you recall that like 50 years back we were dealing with very giant computers like taking this much of space, called mainframe computers. Then we were into desktop era. Then we went into tablet PCs, palm tops, and laptops like that. Now we are into an era called end computer. That's the diskless endpoint, where you don't have any hard disk, memory, or nothing. No embedded OS even. So that is about this next generation computing. Nothing other than like the multiple users sharing a process of a single server, right? But the beauty is that you don't have, it uses this UTMA technology called ultra thin multi-access technology. It doesn't, this is an endpoint where the monitor, keyboards and everything, mouse and everything get connected to this unit called end computing device, right? It doesn't have any disk, no embedded OS within it, so it will take half a minute to load, right? This solution comprises, like, you can divide a single server or a process of a one PC among 30, right? The good thing is, though it is 30, when you compare the server or the central computer, the processing power is very low. Even it depends on the applications that the users are using, but approximately it's not more than 10. Though that the computation power or the function power of the single desktop or the server is divided among 30, the server usage, the memory usage or the CPU usage is less than 10. Right. Let me explain that this solution comprises of three parts. One is the centralized server. It has its own proprietary software called terminal software service, which is able to divide the power of a single server among 30 instances, 30 virtual instances. Okay. And the second one, it uses this desktop streaming protocol. Just recall the word I said, it doesn't have any OS, doesn't have any applications in it. Security device, that's perfect because end user doesn't have anything within that unit because it's a diskless mode. So it uses this desktop streaming protocol to stream out the applications and events and the virtual instance towards that diskless endpoint. Okay. Then the third one is the end computing access terminal. That's where the diskless unit. So see, the lowest cost and very easy to expand and less power. That is 5 watt. Various no embedded OS in it. So we have currently deployed this end computing solution in our organization mainly for the users who are doing data entry part. So I'll show you the electricity cost that we managed to reduce. So it is nearly 64%. This is only the electricity cost. only for 20 endpoints, 64% of electricity we have saved by having these endpoints. See the impact, right? So 64%. When you take the whole TCU, that means the total cost of ownership, we managed to save 35-40% when you compare it with the desktop option. Okay? This is various terms like thin clients. It was in the millennium era, it's called thin client. Then now we are adding a new tag called end computing. That means the next generation computing, right? Right. And another terms, knowledge and data intelligence as service. I hope that this is not a new thing for you all. Because without having on-premises equipment, rather than maintaining a server and spending much money for electricity, space, and AC, we are taking a service from the cloud. Right? That is the most efficient and cheapest way to get a service. And that was in the beginning it's called software as a SaaS, software as a service. Then again they have added platform as a service. Rather than taking a software from the cloud, now we have a platform. Like if you need a server, if you need storage or processing power or a server instance with this much of configuration, it's a matter of just getting it from a cloud, private or either public. Then again, infrastructure as a service. That's another term. Rather than maintaining it at your premises, there are service providers, Dialog, Sri Lanka Telecom, or even Mobitel. They can provide infrastructure as a service as well. And now data as a service. By doing this, we can reduce the energy. That is our theme. Okay? And since that all these services, infrastructure, platform, data can be taken from the cloud, we don't need to have an office. That's where this virtual office. So in Europe, in America, that most of them, even in Sri Lanka, if the office is not exist, it's a shame for us, right? Because the first attempt, because like when you get the appointment letter, you are bothering about the location, you are bothering about the environment, office, and the desk phone, and the desk that you are getting, and the laptop, all the things. But in Europe, that they are motivating to work remote most of the time. Why? Because they are more concerned about saving energy and saving cost and reducing the carbon emission to the world. Even in Sri Lanka, that we are living in an era where connectivity is not a matter. 4G, LTE, broadband connection, fiber connections are there, right? So that I remember that when I was at Millennium, we deployed a solution called hosted PABX solution at SLT and Dialog. So no need to maintain a PABX at your premises. Rather than maintaining it, you can get a virtual instance from Dialog. That's called Box, Office in a Box. That's the package that they marketed. The marketing term called Office in a Box concept. So rather than maintaining it, because if you have your own PABX, see, you need to maintain it, you need to get an administrator for that, you need to pay salary, and not even that, you are paying more electricity bill these days. Just imagine. So rather than doing all these things, you can get so many applications, email, telephone system, finance systems, marketing, HR, all these things exist in the cloud. Okay? Right. So no hardware, no software, no headaches. That is, provide the hosted services for you to start business without complicated huge upfront investments. Right. This is another statistics from Gartner report. It says that by 2014, 30% of IT organizations in 1,000 global companies will broker 2 or more cloud services. for internal and external users up from 5%. See how they will gradually emerge or gradually move into this getting cloud services from the cloud. So in future we might have a global public cloud which exists all these software, platforms, data and everything. So most of the users will get this service as a software, as an application, as a platform, as a service. Right. This is another thing. Microsoft Live, SharePoint Online, Exchange Online, all these things are available. You don't need to bother about having your own emails. So everything exists in the cloud. Right. This is the energy efficiency part. Right. We call that grid, virtualization, energy efficiency, travel reduction and asset disposal. So before I start over, this is the area where the human intervention is more need to be focused. Right? Because there's awareness sessions like implementing power savings in your laptops, you need to, because awareness would help you to save more energy and more cost. Before I start, see the power usage by IT devices. This is a research done in New Industry Software 2007. It says that 39% debited to PCs and monitors, right? And 23% servers including cooling. Rest you say like 15%, 9%, 7%, 6% for the printer, LAN office, mobile and fixed line telephone. See, most of us think that the power usage is centralized to the data center, but these are the very good message saying 39% energy usage goes to the PCs and monitors. Right? How many of you have applied power savings in your PC, in your laptop? 1, 2, okay, 3, 4. Right. How many of you know that there is a way to reduce all the power savings and it's already inbuilt? You don't need to pay a cent. Right? How many of you are aware? Good. I think because my research at Moratour is about analyzing the motivation factors for green implementation in Sri Lanka. And you guys are very good, because when I interviewed most of IT managers and most of directors, they are not aware that they have something called this power saving mechanisms in their PCs. Right? So in Oxford University, they have 12,000 computers, right? Students, but out of these 12,000, 7,000 of these computers they believe to be permanently switched off. Why? Because most of the students doing their work and going home and connecting to their remotely to their machines and doing some investigations, troubleshooting and studying and putting downloads. So they good to know that out of these 12,000, 7,000 believe permanently switched. So they did a campaign, right? By applying these simple power saving mechanisms, they managed to reduce 1,445 carbon dioxide tons annually and 252,000 pounds a year. Okay? It's a great saving by applying simple things. Okay? And not only that, after they completed University of Leeds, University of Harvard, they did the same, and they managed to capitalize the similar advantage, similar cost saving, which Oxford has found. And Gartner report says that PC power management activation can save 2,500 PC organizations more than $40,000 a year. Okay, more than $40,000 a year. Then I was like keen on whether these facts are right or not. So I myself carried out a simple survey and applied like Hibernate and when idle, sleep, put into the sleep mode, and hard disk, when idle, turn it off, like simple power saving mechanism. I think not more than 5, which already inbuilt with the operating system. And I managed to save 24% total power saving. This is a rough figure, 24% of power saving. Okay? And the expected result, 175,613.44, which is closer to what Gartner's, which maps with the Gartner's result. Right. So what we can get from here is there are many mechanisms, like especially in server rooms, power saving mechanism. There are called energy buys, because we all know that servers are running 24/7, right? So there are many mechanisms to save power targeting those servers, but these are simple things by applying, because you yourself can apply it, right? When you are using your laptop, just apply it and see it has a great impact. It has an impact for the electricity bill. Right. Now I am getting into this, how we can save the energy or the cost by reducing this travel reduction. Okay. So what kind of communication methods that you are using for this thing to reduce travel? So in earlier that in like not so long ago, like 10 years back, we used only the voice communication. Is the only way to get touch with another person. Right? But see now, it changed, right? We have many channels. Unified communication, we are calling, because it's not only voice or video, right? In 1990s, then between 2000, then they were into ISDN, video conferencing, like that. But now it's more than that. Just go to a website, HSBC website, and see. You can call to hotline, or you can chat with an agent, right? Or you can have a video conferencing with an agent, or you can check the availability and the mobility. Like that, many channels are around this communication. So that's where this unified communication comes. So many technologies are behind this unified communication to enable it. Right? So just take Skype, you can check the availability easily, right? Whether that person is busy or not in real time. And presence and web conferencing. So if you need to like share your desktop with another person who geographically dispersed, it's a matter of just sending him a WebEx link or video conferencing. So these are many channels around this communication. That's where this unified communication. So this is another common communication silos like instant messaging, voicemail, video conferencing, telephone, web conferencing, email and transcript, audio conferencing, and all comes to one unified. And putting converge into one, that's where the unified communication comes in. Okay? Right. So with this unified communication, it enables the mobility, remote conference, voice over IP, and reduce travel expenses, audio conferencing charge, reduce telephone charge, and the business-wise. Business-wise, wherever you are, you can get connected with your office phone. More or less like you are carrying your office desk phone with you. That's where this unified mobility comes in. So these are the key people in US, the Microsoft Link, reduce cost through converged communication, accelerate business process by integrating communications in applications, Just go and see that hospitality industry completely changed with the help of this unified communication. Go to a hotel website and see that many way of communicating to the reception. It's not only voice, right? You can send SMS, chatting, and many way of connecting people exist. This is the Microsoft Vision for usage. So Link connects people in new ways, like work from anywhere concepts, link across devices, connected experience, simpler to manage, our flexibility. So by doing all these things, what we are trying to gain is reducing the carbon footprint, energy, and saving the impact to the environment. So this is unified communications architecture. You can see that it's a 4-layer model where the bottom layer has the infrastructure layer. That's where the routing, switching, firewall, QoS, all this networking or the telecommunications comes in. On top of that, you have this called control layer. That's where this PABXs, communication servers, and unified communication controlling stuff comes. And on top of that, you have the applications. So the good thing behind this unified communication is you can easily integrate with multiple applications. For example, just assume that you have a in-house ERP system. Okay? So ERP system can be easily integrated with this call control or the messaging system, where wherever you are, you can get a message or online information to your mobile. That kind of thing. So that's where these applications like Cisco Unity Messaging, Microsoft Messaging System, Unified Customer Contact Centers. It's all comes on top of this call control layer. Then the endpoints. Right. So that's about unified communication. So just recall again that our whole ambition is by applying these green IT solutions and reducing the carbon footprint and the energy and the cost. Now I'm going to show you something interesting about this asset disposal.
Did you know that there are numerous ways to make better choices about buying, using, and disposing of your electronic devices? Ways that help you, help your wallet, and help the planet. Say you're buying a new PC. Consider this. Your purchase impacts not only your wallet, but the world's environment too. In fact, some scientists estimate that more than 2/3 of a PC's environmental footprint comes from its manufacturing process, not its use, because it takes a lot of energy, water, and raw materials to make modern electronics. A recent study showed that mobile phones contain over 40 elements. Some, like rare earth elements, require mining in remote places where few environmental controls exist and are critical to modern electronic features. So without thallium, we have no touchscreens. At first glance, you might think all phones and PCs are the same. Look a little deeper. You'll see the amount of electricity they use depends on how your hardware, operating system, and applications are designed. Remember, the purchasing and configuration decisions you make impact the amount of power your devices use and how much you pay to run them. Getting rid of your old devices, how you choose to dispose of them impacts your wallet and the health of our planet. Electronic devices contain dangerous chemicals like arsenic, lead, and flame retardants. If improperly released during the recycling process, these toxins can harm workers, leach into landfills, and pollute local water supplies. If you get rid of your electronics the wrong way, unscrupulous scavengers can swipe your personal or company hard drive data, leading to identity theft, or the sale of proprietary data to competitors, which might cost your company dearly. To help guide you in the eco-friendly purchase, use, and disposal of electronic devices, government agencies, the electronics industry, and other organizations have created several standards. Some apply to individual countries, others to many countries. One important standard is EPEAT, the Electronic Product Environmental Assessment Tool. It's used worldwide by PC purchasers and hundreds of organizations to identify green products that meet users' needs and those of the environment. In 2011 alone, 25% of new PCs sold met EPEAT standards. Today, many companies demand that all new PCs meet EPEAT standards. Easy. The choice is vast, with a menu of more than 2,300 computer products from 46 manufacturers. So, how does EPEAT work? EPEAT uses 8 categories of criteria to evaluate both the PC and the company that made it. Manufacturers and PCs that exceed the basic criteria are awarded silver or gold EPEAT certification. EPEAT certified products must also meet ENERGY STAR standards, which recognize energy-efficient electrical devices. Keep in mind that to achieve ENERGY STAR certification, PC power supply energy efficiency must be at least 80%, with no more than 20% thermal loss. Most electronic devices with operating systems, like PCs, have configuration options that can be used to modify power consumption. For example, a Windows PC can be configured to turn off the screen and hard disk when inactive for specified periods of time. You can also reduce your energy use by using tools that identify apps that consume the most computer resources. All you have to do is modify the app settings. When it comes time to dispose of your old electronics, look for a certified refurbisher recycler, or one of these multi-country certifications: R2, eStewards, and WheelofX. These standards require independent audits to confirm that electronics are reused where possible, or recycled in ways that reduce risk to their staff and to the environment. They also require the refurbisher recycler to wipe all data from the device. Ultimately, these standards encourage recycling by safely breaking down old devices and recovering the raw materials to manufacture new ones. So how can you influence your organization's purchasing procedures and reduce your environmental impact? Require all new PCs to be EPEAT certified in your tender and procurement documents. Encourage employees to use the power-saving features on all their electronic devices. Insist that all organizations that remove your old electronic devices are standard certified. Estimate and publicize the financial impact of your green activities in your annual report. Search online directories to find EPEAT devices or certified recycling organizations, and visit the links section on our website. Plus, EPEAT has a calculator that compares the benefits of buying an EPEAT PC versus a traditional PC. Why not put their power savings table into your next report? Just enter the details about your recycled and reused PCs to estimate the environmental benefits of your actions. By using these tools, you'll make better choices, improve your data security, save money, and most importantly, reduce your environmental impact. Register today and take our quick test to see if you pass the Greener IT Challenge. Earn your certificate and spread the word. Our planet will thank you.
When you are developing more softwares, many applications, there is a high demand for reduce power, because you know that resources there's a scarcity, right? There's a limitation. So you all have to target it to make applications or apps targeting to reduce energy, which will have a high demand in future. Okay? So that is about this asset disposal. So it's nothing other than like reusing. So reusing the IT devices again, or refurbishing, or disposing it away, which will not affect the environment, which will not impact the environment. So that's about my presentation, and in the world make it a better place by implementing IT solutions targeting to reduce energy and carbon emissions of the world. That's it. Thank you. Any questions or anything related to this? So what is he's telling that working from home, how it can reduce the energy or the cost, right? So in the global scale, okay, right. One thing, when you motivate your workers to work from home, right? You don't need to travel up, right? So So you need to bother about the AC, the space, and the electricity much because you are working at home. But in an environment, it's not like an office, right? Because think that in an office, in your data center, you have one email server, a dedicated one for the organization. Another office, they have a dedicated one. But think in way like you have one public server where you can create multiple instances and give it to each organization. Right? So that's where sharing the resources and giving software as a service to the individual. So giving software or the application as a service to the organization. So that's where how you can save energy in the cloud globally. Is it clear? Okay. So motivating workers to work from home by giving IPsec VPN technologies, and because we are living in an era where we have broadband and LTE, 3G, 4G, so we can easily access any application remotely. And even from my iPad, now I can remotely connect. If I have time, I can show you. I can remotely connect to my desktop. Okay? That's called secret receiver. So I'm not using this. This is totally virtualized, right? See, this is my desktop. My desktop. It's not exist there. It's a virtual desktop, right? So you don't need because normally a PC consumes 300 watt power usage. But this desktop is not existent. It's a virtual instance given from the cloud, from the data center. You got an answer? So, since this virtual environment can reduce or consolidate number of servers and create multiple instances per user, per organization, it can reduce the servers, electricity cost, AC, power, and lots of advantages are being introduced. I'm happy because there are one question. Anything other than that? Many software organizations, software companies nowadays targeting to build applications and into like reducing energy. Because when you take communication wise, if you take the applications, there is a very high demand for that. So it will be a good stream for your target, as I think most of you are from software background, to build or to produce software in this area. Any other questions? Thank you very much. I hope that you will get something out of this presentation, and thanks.
Our next presenter is Mr. Prabhutunaratna from University of Colombo. He will present you about the bioinformatics and .NET framework.
Okay. Thank you, Prabhat. I'm sorry for not using PowerPoint. I'm Prabhutunaratna from University of Colombo, Faculty of Science and Department of Plant Sciences. So now you are thinking, what is this biology guy doing here? What's the connect with Microsoft with biology? So today I'm going to give you a brief introduction about bioinformatics and about .NET Bio Framework. So sometimes you may know, sometimes you may not know, and sometimes you may have already learned about this, but there is a field in biology related to computer science called bioinformatics. So, and also there are other fields like such as artificial neural networks. It's also related to biology, and this is another field. So, first of all, what is bioinformatics? So, bioinformatics is a newly emerging interdisciplinary research area. So, what is interdisciplinary? Interdisciplinary means it has overlapping areas with various type of fields. So, what are these fields? I'm going to talk about later. So it acts as an interface between, mainly it acts as interface between biological sciences and computer sciences. So this is our overview of bioinformatics. It has a lot of overlapping areas: biology, medicine, physics, statistics, mathematics, and mainly computer science and biology. So it also can be defined as an interpretation or analyzing biological data using computer science. So what are the biological data being produced? So that is important question. So there are so many biological data are being produced, but I'm not going to talk about all of them. I just mentioned about few of them, and I'm target only sequence data. So sequence data are DNA sequences, RNA sequences, and protein sequences. So what is the importance of this data? What we can do with this information? So this information decides what you are. Actually, DNA decides what you are and why you are here. So all of you like computer science. So so that decides your genome, your instructions inside of your DNA. So likewise, all the things in the natural, in the life, maintained by the DNA information. So there are so many importance of this data. Only talk about one special application. So bioinformatics concern with so many applications. It's not a theoretical science. Biology is a theoretical science, but bioinformatics is an application field. So I'm talking about drug design. So what is a drug? A drug is a medicine. So if we have a disorder or disease, what we can get? It's medicine, right? So drug designing. So in previously drug designing takes so much time, but with bioinformatics information, we can model drugs using this information by using computers. And actually, who are they? This is the ultimate goal of this data, but we have ultimate access, we have ultimate possibilities, we have unlimited possibilities with this instruction, with this information. We can do so many amazing things. So we have some limitations, some ethics. So actually this bioinformatics is still in the under development phase. So in future, sometimes we can produce like these organisms. We say to these organisms, genetically modified organisms. Or nowadays, as actually you are eating genetically modified organisms like crops, like foods. Most of them are genetically modified, but it's good, right? So nowadays we are using these informations to improve our crop, and produce so many, find so many questions to unsolved problem in the nature. So all of you know what is insulin, right? Insulin is, it's a medicine for diabetes. So do you know how to produce insulin? Scientists, any of you know how to produce the insulin? So insulin are produced by microorganisms, like I can say a bacteria. So we transfer our gene, our insulin produced gene to bacteria, so we can produce insulin. So with this information, we can do so many things. So in the earth, we have mainly three types of organisms. This categorization is some may not have correct, but for using simplicity, I will categorize them into three parts: microorganisms, plants and animals. So all of these organisms have DNA and RNA. So all of these organisms maintained by information of the DNA. So every individual, every organism consists with cells. So cell is the primary living structure. So in the cell, there are various types of cell in organism. So let's move on to inside of a cell. This is a figure of cell. So in the center, you can see a structure, organelle called nucleus. So let's move on to the nucleus. So in the nucleus, you can see X-like structure. So in the nucleus, so this X-like structure called chromosome. So chromosome is built up with DNA molecules. So you can see DNA molecules highly compact with a protein and create these chromosomes. So this is the structure of DNA. So let's talk about the inside. So this is the only important thing to you. So this is the alphabet of nature. So how we can store the information in the DNA? So there are 4 letters. So what are the letters? Thymine, adenine, guanine and cytosine. So we call TAGC. So in adenine complement with thymine. So there are 2 strands in the DNA. So you can see there are 2 strands in the DNA, and in the middle you can see these nitrogen bases. So that's how nature storing the information. So it's very simple, right? So English alphabet also have 26 letters. So life of nature only have 4 letters. So it's simple. So we can find clues, we can find information by looking the sequence. So actually the real situation is different. So you end up with this. Any of you can identify any information from this? So there are, but actually there are hidden information. So we can't do it by manually. So that's why we need computers. So we are using computers to analyze these sequences. So as this have only 4 letters, it's simple, but yet so mysterious. So still we are finding clues about this information. We are trying to analyze this information. So let's say human genome has 3.1 billion base pairs. It's a large amount of base pairs. If you take one letter in human genome per 1 second, you will need 100 years to write. So it's large amount of data. So in this 3.1 billion, you will only need 2.9 bases for storing instructions. So how can we find this instruction among these 3.1 billion base pairs? So that's why we need computers. So what is this genes doing? These genes are producing proteins. The proteins are key functional unit of organism. So by producing proteins, so storing information for production of proteins. In the genes, there are instructions for production of proteins. So by producing proteins, we are maintained alive. So genes decided where, which and how much proteins are produced. All of the information are inbuilt in these sequences. So we don't know yet. Some of them we are still analyzing of them. And next I'm going to talk about what is a gene. Gene is basic physical and functional unit of heredity made up of DNA. You can see gene is the region of DNA storing the information of production of proteins. So what are proteins? proteins are the main functional unit of the organism, and it's created with 20 different amino acids. So it's type of molecule. So these molecules combine with and create proteins. So these proteins, what is these proteins doing? It actually, I can say, most of the functions of your body is the result of proteins. And how proteins can be produced? It uses a nature standard of a nature, so we call it standard genetic code. By using standard genetic code, DNA producing proteins. So now you have overview. This is chromosome and this DNA. So this region called gene, and you can see there is information. So in the DNA you can see ATG, AACC like sequence. So it's copied to another type of molecule called RNA. RNA only having U. In the case of T, it's a special type of molecules. It only have single strand and it's used to copy DNA data to another place. So then this mRNA moves to another place and produce proteins. Produce proteins by linking amino acids according to that standard genetic code. Like say AUG in sequence, we can produce methionine. So you can see AUG methionine. So likewise we can produce proteins, and we have so many data. We can say it's a big data. So there are millions of records in the sequences. So how can we analyze? That's why we need databases. So there are mainly two types of databases. Primary databases and secondary databases. So primary databases store nucleic acid sequence, mainly DNA and RNA, and protein databases, protein sequences, amino acid sequences. So secondary databases storing the analyzed data of primary sources. So for an example, pattern databases, RefSeq, and I'm just only talk about nucleic acid sequences. So there are three main types of nucleic acid databases in presence. So EMBL, GenBank, and DDBJ. So all of these databases are collaborated in one another, and we can retrieve information from one. So next I'm going to demonstrate predicting the protein of structure using sequence data and using online tools NCBI BLAST or GenBank database and protein structure database called PDB and molecular viewer RUSI. So you can see BLAST is basic local alignment search tool. If you click, you can come up to this page, and what we are doing, we have a protein we have a DNA sequence. This is our DNA sequence. So by using this DNA sequence, we are trying to predict a protein structure. So why we are doing this? If this sequence is produce a protein, this protein is caused to a disease. If we can find protein, if we can find protein structure, we can design a drug. So I'm going to copy this and select nucleotide BLAST and paste this and do a BLAST search. So I'm getting this result as output. So it's a similarity search. So this is the best hit. So it's compare the sequences in the database to our query sequence and give the similarity search and find the similarity about our sequence and sequence in the database. So give the best result out of these sequences. So if we click this accession number, we can get into this information. I am trying to, this is already defined data. So I used unknown sequence, but in databases we have defined data. So I can find 14 for this gene. So if we click this 14, we can see the amino acid sequence. So I said earlier, proteins are made up with 20 different amino acids. So if there is a standard code for one letter code for amino acids, so this sequence made up with that standard code. So if we get FASTA format, we can get this sequence. So if we copy, and if we paste to another blast, now I am selecting blast P. Earlier I select blast N because now I am using protein sequence. So I just use blast P, and now I am going to find a structure for our protein. So I am going to search protein data bank. So click blast. So earlier, I can come up with few results. So this is the structure of our protein. So I get this accession number copied. So I just put in another database. I earlier mentioned PDB is structured database. So I give a search. I can come up with structure of this. So I can get this file. So I open molecular viewer. So you can see our protein. So likewise, we can do so many things using this computer simulation. So likewise, if we know structure of our protein, we can produce drugs. So that's the end of my first part of my presentation. Now I am moving to second part of my presentation. I am going to give an overview of .NET Bioframework. So what we need, why we need .NET Bioframework. So from .NET Bioframework we can develop applications, we can develop tools for bioinformatics. So what is .NET Bioframework? .NET Bioframework is an open source, reusable and language neutral .NET library and application programming interface. So it's language neutral. So we can use any language on top of the .NET framework. We can use C#, we can use VB.NET, and any language among .NET we can use for development. So components of .NET Bioframework, we have parsers, we have formatters to read and write bioinformatics formats. I earlier said about FASTA format. So we have specific parsers for read data from FASTA format, and parsers also doing conversion of these formats to framework object model. So this framework object model is format independent. So we can use this object to analyze and subsequent operation and do subsequent operation of our sequence data. And formatters are used to write our sequence data to any format. So these frameworks support for DNA, RNA, protein sequences and algorithms, and there are special type of algorithms. There are very scalable algorithms. You can see there are large amount of database large amount of data in the databases. So we have scalable algorithms to retrieve information from them, and especially web connectors for getting information from web services like NCBI. So, what is the primary objective of .NET Bio Framework? .NET Bio Framework used for reusable, mainly it's used for develop user-friendly applications. Most of the bioinformatics applications are not user-friendly, so we can use this framework to develop user-friendly applications also. So, what is the benefits of .NET Bio Framework? There are reusable libraries, and actually I can say .NET Bio Framework is more extensible in design, so we can extend our .NET Bio Framework with our own code. We can develop our own algorithms, and also it can be implemented with any .NET language. So this is the overview of .NET Bio architecture. It has mainly 4 namespaces: Bio namespace, Bio IO, Bio web, and Bio algorithms. So, and also not only using .NET Bio Framework, we can get in information from our own applications to .NET Framework. So it is top on our own applications also. So it's another demonstration. Retrieve information from NCBI web service. You earlier saw what is NCBI. So it's a retrieval system of GenBank. In the GenBank we have so many DNA, RNA sequences. So from this framework we can retrieve information from NCBI web service. So for this we need to install .NET Bio Framework into the computers. So it's an add-on to Visual Studio, and you can download it by Codeplex. So steps to getting information from the web service. First thing we need to do is define the sequence and create and configure a web service handler, define the request and submit the request, process the return data. I will explain it in detail. So I just installed it, and so I select Visual C# and you can see there is an extension for .NET Bio Console application, and you can develop GUI applications also. Only thing you need to do is set the references for .NET Bio Framework. So I am selecting this. So it gives us options. So in this framework we can easily do so many bioinformatics things. So I'm not going to talk about this. There are pairwise alignment, multiple alignment, simple sequence assembly, de novo assembly. So unlike branch service, so that we need to develop our application. So I just click finish. It's add all codes. It's add methods and specific codes to our application, and we just need to call these methods and to do specific modifications to this code. So I already created one. So first I have to load my sequence. This is my sequence. We can use parsers for getting this sequence from a file. I just put it down to this, get it down to this. So this is our sequence. So next thing we have to configure web service handler. So I'm going to create a new web service handler. So NCBI blast handler, and I just create an object of configure parameter. So I'm using default proxy and for our retrievers. So this is the parameters, and earlier you saw I said about what is the database. So at this point our database is BLAST N, and database BLAST N, database is non-redundant database, so we call NR, and we need to submit our request to the database, to the NCBI, and get the job ID. After we are getting job ID, we can retrieve our information. So actually we have waiting time unless we can't get the information from NCBI. So we need to set a service. So status we need to get a status request, so we can monitor what's going on inside our application. So we can set the status of our application and set the waiting time. And after that, finally, we can submit our job ID and we can get the result. We use fetch result sync method, and we can submit our job ID, and we can put our search parameters. What is search parameters? I said about this is BLAST type and database type. So then this fetch result sync method return a list. So from this list we can extract our information. So I just create a console application. If you like, you can create a GUI application also. So I just put in for each, so I could get information from the NCBI. So I just forgot to tell you something. So this is iSequence. iSequence is a parser. I said about what is parser. Parser is convert our sequence into object model. So now we can modify, we can do operations independently in the format. So there are alphabets in DNA. So I give my sequence and create iSequence. iSequence is an interface. So likewise, I can create a small application to retrieve information. So if I run this, I can get this information. You can see there are nice results in the NCBI database. So now we are just getting the console application. So we are getting data. So if you like, you can use this information to develop amazing applications. So there are amazing applications in .NET framework called .NET Biosequence Assembler. Right. We can use these information. We have nice documentation in the .NET Bio framework. So if you like, we can develop amazing applications using .NET Bio framework to develop bioinformatics applications. So if you have any questions, there are no any questions. So I am not expert in this field. I am also learning. So if you have any doubts and if you have any questions, you can contact me. And thank you.
Dushan, can you tell me who is the Twitter audit and the Brain Teaser winner?
I started the Brain Teaser. We got few answers and creativity, and actually unexpectedly there were two answers as well. So there was a person who personally in a creative way with the two answers. So it goes to this is Mandesha Vijayasekhar from UCS.
So enough. Thank you for all. refreshment is ready in outside.